Hello everyone. So we'll start the session today. Last class we were talking about different Spring Boot terminologies and some theories about Spring Boot. And last topic we had covered was dependency injection and inversion of control. And we had also discussed like what are the different ways to achieve dependency injection. So we had discussed about constructor based dependency injection and setter based dependency injection. So let's see an example each for how this can be achieved, like constructor based dependency injection and setter based dependency injection. We had talked about that employee address example, right? So let's say there's an employee who has got certain attributes, and this the employee has some address as well. So we need to like see how this address dependency can be injected into the employees class. So see, this is an example of a constructor dependency injection. We have our employee class, and this address is present as a data member or a member variable, and we have created the constructor of this employee class, a parameterized constructor, and we pass this address as the parameter here, and this is the initialization of this data member. So in this way, this particular dependency, what is the dependency here? Address is the dependency here, and it's being injected into the class employee. So this is an example of a constructor dependency injection, because the dependency address is being injected with the help of a parameterized constructor. So this is an example of constructor dependency injection. So similarly, this can be achieved by using uh, setter dependency injection as well. Let's see how this can be achieved. So the same dependency injection we'll see through a different mechanism. So see, this is a setter dependency injection. You have already known how to like generate the getters and setters using your editors. So this is like setting the address. We have our address, we have the employee address available as a data member, and what we are doing, we are creating a method that is a setter method, and in the setter method we have a parameter named as address, and we are like initializing this using this setter method. So this dot address equal to address. So whatever member variable that we have on the top, that is being initialized in this particular method. So this is an example of setter dependency injection. So this example we had already discussed, so you can see how in code this can be like achieved. Constructor dependency injection can be like achieved using a constructor where you can like inject the data member and you can initialize the data member. So address is now available in your employee class. Similarly, in setter dependency injection, you can use this setter method to inject this dependency, to inject this address dependency. We'll see how this can be like further done using a single annotation, and we don't even have to like write these constructors and setters, but those annotations are like built on top of this, and we'll see how those are like when we start using annotations it is like very easy, because you have to like write very little code, and a lot of like boilerplate code is like removed. So annotations make our life very easy. So Java annotations are like heavily used these days. Earlier in Spring Boot, a lot of like XML configurations were done, but now when we create our project, our Spring Boot project, we would generally have to just have a single XML file where we have to like manage the dependencies, and rest everything would be done by our Java annotations. Annotations are simply like annotations are basically written using like at the rate and then followed by some keyword. Those keywords are like specific to Spring, and we'll use them like heavily to make our life easier. Okay, we'll go through some more terminologies here. So when we start creating Spring Boot project, so we would come across this term very often, like Spring Beans. So what exactly like Spring Beans are? So uh, we need to like understand what the Spring Beans are, because you will be like hearing this terminology a lot while making the project, or someone might ask you like what exactly a Spring Bean is. So in Spring, the objects that form the backbone of your application and that are managed by the Spring IOC. So Spring IOC is basically inversion of control container, and these are basically called beans. So the objects of our application that are managed by our Spring container. Okay, TJ. So the declaration of the address is like address. So this is like I'll show you. Yeah, this is the declaration of address. So you can, means as of now, like I have skipped the private and static, or private and some data member, anything like that, right? So see, if we do not have any access specifier specified before any data member, we have already known that that is of a default scope, right? So we have already studied about four scopes, that is default, private, protected, and public. So if you do not provide any scope here, if you do not provide anything like private, public, or protected, so by default this is termed as default in Java. So this has default scope, that is this address is available within the package, means any number of classes that you can create, those classes, if they like inherit this class, this address can be made available to all those. So this has like default scope. Yeah. So okay, so what else do you want to like understand, TJ? See, okay, you might be confused about the data member as well. So, data member here itself is like your address. This is a user defined data type. So, usually we had like taken example of string, integers, and some other things. But this address itself is a class. This address, let's say this address is an existing class, and this address has some fields. Let's say this has some street name, some your house name, your zip code, and the let's say the state. So this address is a class, and this is a class data type or a user defined data type. Yeah, yeah, yeah. So this is a user defined data type address. Means this address is basically a class, and in the class you have some data members. Like this address can have some data members. It can have a string, street name, it can have a zip code of integer type, and it can have some state name that is also of a string. So all these fields are in a class, and that class is named address. And this particular address, now we want that that entire class can be injected into the employee class. So we can do it by two ways, that is like constructor injection and setter dependency injection. So this is the data type. Address itself is a data type. This is a user defined data type. We have defined this class. I do not have that in the slide, but I hope you got that right. TJ, is your doubt clear now? This is a data type. This is a user defined data type. We have the class defined for it. Like it has different fields, and we have injected this address over in this particular class, in the employee class. Let me know if it is clear or not. Okay. So, okay. So this address is like okay, it will be more clear when we basically take the examples, we take further examples. But I think this should be like clear by now. We had like discussed, we have like created a lot of classes in core Java training as well, where means let's say you created one employee class, you created a student class. So these classes are itself a data type as well. Means these are your user defined data type. Means as an when we'll create this Spring Boot project, right, we will do a lot of this uh, uh, dependency injections, so it will be like more clear. But understand for now, this address is an existing class which we have defined somewhere, and we are trying to use as a data member. We are trying to use as a data member or a instance variable. You have created instance variables, right? We talked about these terms like instance variables. So these are basically instance variables or data members, and we are like initializing these data members using a parameterized constructor. This employee class has a parameterized constructor where we have taken address as a parameter, and we are initializing this parameter. So similarly, this is done by, yeah. So similarly, this is done by setter dependency injection as well. So here as well, we have the address as a parameter to this method. This address is a parameter to this method, and this dot address equal to address. This means that when we talk about this dot address, this means the instance variable that is like assigned to the top. So see this left hand side and right hand side of this statement. When I talk about this dot address equal to address, that means this dot address refers to the address which is declared at the top, that is your instance variable, and is equal to address. The address that is on your right hand side, that is basically the address which is coming as a parameter in the method. In the set address, we have a address parameter, right? So that is the one which you are seeing on the right hand side of the equal to sign. So understand this, we are initializing the instance variable itself here using a setter method. So setter method and getter methods, you have already known how to generate those setter and getter methods using your editor. So let's go over another slide. Yeah, we'll go through some more terminologies because see, there will be like some theoretical classes in your initial classes, because there are a lot of terminologies. If I start just the project and then I start writing down the annotations, you won't understand like why these annotations are because why these annotations are used and what's the use. So I'm just giving an overview. Once we start developing the application, I'll give you again this overview. Means that time it will be like easier for you to relate why these annotations are getting used. So let's see this terminology. You will hear a lot about the spring beans. So spring beans are like very popular terminology while building the Spring Boot project. So in Spring, the objects that form the backbone of your application and that are managed by the Spring IOC container are called beans. So Spring, when the Spring application starts, right? When the Spring Boot application starts, basically a container runs at the backend. That is your Spring IOC container. And that Spring IOC container is basically responsible for managing a lot of Java objects. So when I talk about this Spring Beans, right, this is a kind of Java object itself. So let's say we have some employee class or a student class. So these can be considered as a bean. Let's say we have made that class as a component and we have injected that employee or student class in some class. So the Spring container basically takes care of managing it takes care of managing and instantiating this particular Java object. So this Java object is basically called like Pojo objects in Java. Let's say we created some employee class or a student class or a address class, and we are marking that as a dependent object in some other class. So these classes are basically called Java Pojo objects. It's Pojo objects, and these Pojo objects are also called as Spring Beans. The Spring container which runs at the back end of your application, that basically is responsible for instantiating means creating the object, right? Eh, so instantiating means creating the objects and assembling and managing the entire Spring Beans. So a Spring Bean is an object that is instantiated, assembled and managed by a Spring IOC container. So once you start your Spring Boot application, there is a container. That container is called Spring IOC container that starts at the backend, and its job is to like manage entire beans of your application. Means there can be like a lot of beans which are there in your application, and it is managed by that Spring IOC container. And see, otherwise a bean is simply one of many objects in your application. So you can have like lot of objects in your uh, project. Like you will require these objects to create HTTP request. We'll see further how we use those particular classes or objects. So these are like also called Pojo objects or Spring Beans. Means understand for simplicity, like the uh, 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 classes that you create, like employee class, address class, student class, or some other classes that you create which has some data, member variables, and these classes are basically used as part of a request. Means you are, suppose let's say you are creating a REST API and you want to like pass some kind of payload in that particular REST API, and these classes are used in that. So these classes are basically managed as Spring Beans in your Spring Boot project. Okay, let's talk about Spring Container. See, org.springframework.context.application context interface represents the Spring IOC container and is responsible for instantiating, configuring, and assembling the beans. So this we have talked just now, like the Spring container. So when the Spring application starts, Spring Boot application, I mean, when the Spring Boot application starts, an application context is created at the backend. And this application context basically comes from this import like org.springframework.context.application context. So this is an interface, and this represents your Spring IOC container. So this container runs at the back end of your application. Means once you have started your Spring Boot application, this application context creates a kind of context within the entire application, and it manages your Spring Beans. It manages the entire life cycle of your Spring Beans. Means it will instantiate means creating the object. It will create the object of your Spring Beans, it will configure them, and it will also like assemble them or like inject them as your dependencies in some other class. So this is the role of Spring container. So the container gets its instructions on what objects to instantiate, configure, and assemble by reading configuration metadata. Okay, so when we want to like use this Spring Beans as a Spring Beans in Spring Boot project, we write some kind of configuration metadata. Means there were two modes of maintaining that configuration. Let's say I have some Spring Beans and I want to manage them. How do you manage them? So you need to have some kind of configuration. So earlier those were like done by writing XML files. Means if you want to like make any class as a Spring Bean, so what you will do, and you want to like manage the life cycle of that particular object, what you will do, you will create a XML. That was the old traditional way that we used to create XML files and then uh, inject those dependencies. So dependency injection and all those things were done earlier using the XMLs. We have to like basically uh, specify which object is like dependent on which particular class. So those dependency management things were done using an XML file. But now we are doing that using our Java annotations. So Java annotations like make the life of any programmer very easy because it's like more readable and you don't have to like maintain XML files. So configuration, the container gets its instructions on what objects to instantiate, configure and assemble by reading configuration metadata. So let's see. Configuration metadata is traditionally supplied in a simple and intuitive XML format. Now, Java-based configuration is used for the Spring applications. So now Java-based configuration is like very much popular because it's easier to write a Java than it's easier than writing an XML. So maintaining XML is also always a tough task, and that's why this Java annotations, writing it through the help of Java annotations, this has become very easier. So we will use the Java annotation way in our Spring Boot project to maintain everything. Like whatever Java annotations are available, we'll try to like maximize their usage such that the programming becomes easy. Means creating your projects and like injecting the dependencies within your project, those things like become very easy. So we'll heavily use Java annotations. So this is about the Spring container and Spring Beans. Let's move forward. So see, this is the diagram. See, here this is our business objects or some Pojo classes. So Pojo classes, I mean, is, let's say you have like your address class or your employee class or your student class, and you want to basically use them as a Spring Bean, and these have to be injected into some classes. So what your Spring container does. Spring container means Spring IOC container. This runs whenever you start your Spring Boot application. So it needs the help of some configuration metadata. It needs the help of some configuration metadata. And this configuration metadata can be provided in the form of an XML, or it can be provided in the form of a Java annotated class. So you can provide configurations in any manner, like the Java configuration way, or it can be in the form of an XML. So the Spring container takes this information and it produces a fully configured system which is ready for use. So your Java objects are basically managed by the Spring container, and these Java objects or business objects are also called Spring Beans. So your Spring Beans are like managed by the Spring container and it is now ready for use. Means you, let's say you have like several classes. You have controller layer, you have a repository layer, you have service layer. Each has its own usage, and you can use this Pojo or Spring Beans anywhere. You can use this Spring Beans anywhere in your project. So we have already talked about the layers in our project in the Spring Boot architecture, right? So Spring Boot architecture, we generally have like three layers. One is the controller layer, that is your front part for receiving any HTTP request. So when the client sends any request, it comes to the controller, and the controller passes that particular request to the service. And in the service, you basically have the entire business logic. Means whatever business logic you are writing, those things should be in the service. And this service further calls your repository layer. Repository layer is basically data layer. In this data layer, basically we write the logic for how we want to like interact with the database for receiving any information. So your database has some tables, it has some information, and in those tables you like feed a lot of information, and your repository layer will be basically pulling up those information and inserting some new data in the database. So all those operations are basically done in the repository layer. And now what happens, that repository layer sends those information back to the service layer, and service layer kind of want to do some kind of filtering or some kind of like processing on that particular data, and then the service layer basically sends that information back to the controller, and here the controller creates a JSON response, and that response is shown to the user. That response is basically shown to the user. So that was the architecture or the life cycle of Spring Boot that we had talked earlier. So that is that's the life cycle, and this is your business objects being maintained here by the Spring container, and with the help of some configuration metadata, it makes the configured system, which basically is used by our application. So now that we have some Java objects in our application and we have Spring Beans, so there is some scope of Spring Beans as well. Scope means, when I talk about scope, I mean that how far that bean is like accessible, or when that bean is created, in which type of project, what kind of beans are created. Let's say we have some kind of like server client architecture. So in that kind of Spring Boot project, what kind of like beans will be created? Or let's say we have some chat application. Let's say we have some Facebook Messenger. So in that case, let's say someone created one Facebook Messenger using some Spring Boot application. And on the backend, like what kind of beans are like maintained? We'll talk about these things. So there are like six scopes of beans, and by beans I mean that these are Spring Beans. So the first one is the singleton Spring Bean. So what singleton Spring Bean is, it is also the default Spring Bean. So when you create a Spring Bean and you don't specify anything, so it is by default a singleton bean. And your singleton bean scopes a single bean definition to a single object instance for each Spring IOC container. So when in Java you have this singleton bean, right? So it is like a single instance, means a single object is created which is like available throughout the Spring IOC container. Means what it means, that whenever your Spring Boot application has started, that Java object is available just as a single object within your entire application. When you run your Spring Boot application, an application context is created, right? And within that context you have like several Spring Beans. So this particular Spring Bean has a single instance, means single appearance of an object, within the entire application. So that is why it is called singleton. Singleton means by default means it refers to being single. So single means one single particular object instance within the entire Spring IOC container. So sometimes you might be asked even in the interview questions like what are the different bean scopes? What are the different bean scopes? So the first one is singleton bean scope as well. So from interview perspective also this question is important. So singleton is that bean scope where a single bean definition is allotted to a single object. That means only single object appearance happens for that particular object within the Spring IOC container. Now let's say we have our second bean scope. This is prototype. So what do you understand by prototype? So it means scopes a single bean definition to any number of object instances. So we have one bean, and for a particular bean we can create any number of object instances. This is just the opposite. Means in singleton a single bean definition was given to a single object. Means we have created one bean, means we provided some definition to one bean, and with the help of that definition we are able to create just a single object. But using the prototype bean scope, using a single bean definition we can create any number of Java object instances. Means using a single bean definition multiple Spring beans can be created. So that is the rule of prototype bean scope. Now let's see some other bean scopes. Next is request bean scope. So what do you understand by request bean scope? So it scopes a single bean definition to the lifecycle of a HTTP request. That is, each HTTP request has its own instance of a bean created off the back of a single bean definition, only valid in the context of a web aware Spring application context. Now, this third bean scope, that is the request bean scope, this is like heavily used in a server client architecture. So let's say we are making some HTTP request and we want to get some kind of HTTP response. So when we will create our REST APIs, right, there will be a lot of HTTP request and HTTP response. So request is the payload that we provide to our APIs, and response is what we expect our application to send in the form of a JSON. So we send our request as a HTTP request, and we get our response as a HTTP response. So this kind of like whenever we have some scenario like this and we have like different beans managed within that, so that bean is basically called a request bean. Means within the life cycle of your HTTP request and HTTP response there might be a lot of Spring beans which are maintained, and those are like created. Means when our Spring Boot application is run, a Spring application context is created, and we send a HTTP request to our server, and the server gives us a HTTP response. In between all of this there are some Spring beans which are used. These Spring beans might be used in your HTTP request, and Spring beans might be also used in your HTTP response. So these type of Spring beans which are used are called request bean scopes. So let's see other bean scope. We have a session bean scope. So let's see what this session bean scope is. So session bean scope scopes a single bean definition to the lifecycle of an HTTP session, only valid in the context of a web aware Spring application context. So understand this scenario. What is the session bean scope? So session bean scope is basically like used in a session management kind of thing. So let's say you have like logged in into Instagram, or like you have logged in into Facebook. So once you have like provided your credentials, right, means there is some kind of session created already, right? So you don't have, let's say, even if you close your application, again if you just click on your application, you are again able to log back in. You don't have to like enter your credentials anymore, right? Means once you have provided your credentials, you have logged in, and let's say you have saved your credentials. So again if you like close your application, and again if you like open your application, you are still able to go back to your profile, and you are able to like navigate to different parts of your application. So that is like some kind of session getting managed. Means your user session is already available within that particular application. So whenever we want such scenarios, like you want to create any employee management system, and once you have provided your credentials like the username and password, and you have provided and you have clicked on sign in. So once you have signed in, and so what happens, a kind of session gets created. Means this is mainly associated with your sign in features, like sign in and sign out features. This session is heavily used. Means that particular user session is available in the application. So whenever the beans are created here, so those are like your the scope of these beans is in the entire session. Means once the session is ended, only then the scope of that bean will be ended. Let's say we try to like end the user session. Let's say we try to like log out from the application. When that logout thing happens, then that spring beans will be destroyed. So in the entire session, this spring bean will be available. So this is the scenario where bean scopes are used in a session scope. Now let's say we have some other bean scope, that is application bean scope. When we like talk about this application bean scope, this is like a single bean definition is given to the life cycle of a servlet context. So means in terminology, in definition wise, if you read, this is like hard to understand, but understand that there's a spring bean, and that spring bean is available to the entire application. Means for as long as the application is running, that spring bean will be available. Means see, in the previous example we had a session, uh, uh, means let's say our application is still running, but we thought of ending the user session. We logged out and got the user logged out from that particular application. So that spring bean is terminated. That spring bean is terminated. Now that we have some different kind of spring beans, we want some spring bean to be always available as long as the application is running. Means some Java objects to be always available as long as the application is running. So those kind of Java objects have application scope. Application scope means the Java objects can have their life cycle within the entire application. As long as the application is running, those Java objects are accessible. So that is basically your application scope. Now let's go to the last bean scope. This is WebSocket bean scope. So this WebSocket bean scope scopes a single bean definition to the life cycle of a WebSocket, only valid in the context of a web-aware Spring application context. So this WebSocket is this last bean scope. This is actually a bit advanced. So what happens with the help of a WebSocket? So when I talk about WebSocket, it means that this kind of socket functionality is basically used in your chat applications. So when we implement any chat functionality, right, that means you chat with like one person or with like multiple persons. So in that case, basically at the backend there is some kind of web socket created. So web sockets like help in like fast mode of communication. Means whenever you have something of some feature like a chat functionality, right? In the chat functionality, as soon as someone types in a text message to you, you instantly get that text message, right? And you are able to instantly reply to that text message as well. So such functionalities are basically like created using some backend technology, and that technology is basically called WebSocket. So if we have some Spring Beans within that WebSocket application, those have a bean scope of WebSocket. So WebSocket is basically like used in like real-time applications where you want to have the request and response like in real time. Mean a chat application is basically a classic example of a WebSocket. And whenever you have some Spring Beans which are available in your chat application, those will be basically your WebSocket bean scopes. Those will have like the scope of WebSocket. So this is like one of the interview questions as well. Means this is like important for knowledge perspective. Even if someone asks you like what are the different bean scopes, you can like give them the names of these bean scopes and what is your basic understanding of the bean scopes. So sometimes this question might be asked in interviews as well. Let's move to other slide. So we will talk about dependency management in Spring Boot. So when you create your application, right, you will need some dependencies. Okay, I'll talk about the example when we created our JDBC connectivity example in core Java. So what we did, we added some kind of MySQL connector jar, right? Can you recall that we added some MySQL connector jar when we created that JDBC connectivity? We went ahead and added in the libraries some external jar, MySQL connector jar, right? So that means that we added some kind of like dependency for your project. We added some kind of jar required for your particular application. Means when you create your JDBC connectivity, you need some MySQL connector jar, or if you are using some Oracle for as a database, you need some ODBC jar. So in our JDBC connectivity, what we did, we were trying to connect to a MySQL database. And when we were trying to connect to the MySQL database, we needed a MySQL connector jar to be added into the library of our application. So when we create a Spring Boot application, we don't have to do that things. We don't have to do those things. We don't need to manage the dependencies in such a way that we have to like go ahead and add any external kind of jars. What we can do, we have like build tools. There are like different build tools like Maven or Gradle. So this Maven is like provided by uh, Apache company. So Apache Maven or Gradle, these are like build tools, and these can help to manage dependencies in our Spring Boot application. So what we do is we will create a pom.xml file. Okay, let me talk about this. So the Spring Boot Maven plugin provides Spring Boot support in Apache Maven. It allows you to package executable jar or war archives, run Spring Boot applications, generate build information, and start your Spring Boot application prior to running integration tests. So this Apache Maven, this is a build tool, and it gives us several benefits. Like it helps to get all the dependencies. It also helps to run your Spring Boot application. It helps to create the build of your project as well, and it helps to basically start your Spring Boot application. So just see this example, how the dependencies in the Spring Boot are managed as part of a Spring Boot application. So this is an example of pom.xml. The snippet that you are seeing below is a pom.xml. This is the only XML which we will be maintaining in our entire Spring Boot application. So once you click on your Spring Boot, once you start creating your Spring Boot project, right? This pom.xml is automatically created with some dependencies. And see, in this tag, right? In this parent tag, you are able to see something like Spring Boot starter parent, right? So this is like some kind of dependency which is available in our Spring Boot application. Now let's say I want to add some MySQL dependency. I want to use MySQL as a database in our Spring Boot application. So there is some kind of dependency tag. In dependency tag, we will go ahead and add that tag for MySQL connector jar. Means whatever the dependencies are there, we will add it in the form in the pom.xml itself, and automatically the Spring Boot application will be able to add those dependencies in our Spring Boot project. Means those will be added as libraries to our Spring Boot project. So this entire thing means whatever we provide as dependency in this pom.xml, Apache Maven goes and it picks up from the repository that particular dependency, and that dependency is provided to your Spring Boot project. So this Apache Maven helps to like provide dependencies to a Spring Boot project. It helps to like generate the build for your project. Means once you create your project, you should always be able to like build your project, right? Building your project is basically like running the entire tests, running your test suits, and it is basically like checking if you have some type of like compilation errors or such kind of things. Those are like available in build. And also in this pom.xml, right, you will provide the information what kind of packaging you need for your project. Let's say you have written down your all the modules of your project. So if you want to like package your project as a jar file, if you want to like package your project as a war file, those information can also be provided in this pom.xml file. So this is the XML file where you can like add all the dependencies, whatever dependency or libraries you need for your project, what kind of JUnit or the JUnit dependency you will be requiring for writing the test cases, how you want to like package your application, all this information you will provide in this pom.xml. So dependency management is done by this Apache Maven tool, which is uh, which can be basically used for dependency management, packaging your application, generating the build of your application, and also it helps in running your Spring Boot applications. So we'll see we will need some kind of like dependencies to be installed. Like we will need Apache Maven to be installed in our application, and also we would need some kind of like tools before getting started with our Spring Boot project. So but this is the role of Apache Maven. It is a dependency management tool which helps in packaging our application, it helps in generating the build, it helps in resolving the dependencies required for our application, and it helps to run our Spring Boot applications. Let's go to another slide. So we'll go through some of the annotations. See, whenever we talk about Spring Boot annotations, a Spring Boot annotation would be something like this. Like it starts its prefixes like at the rate and then followed by some keyword. So let's talk about some of the Spring Boot annotations that we will heavily use. So Spring Boot configuration annotation. See, what is the use of? I'll tell you for now. Like, let's first study about this Spring Boot configuration annotation, and we'll know like whether how much we want to use this or not. So this Spring Boot configuration annotation, this will not be like used much. Means it was used earlier, but now we won't be like using this. But we need to like understand why we need to understand is we will use one annotation that basically internally uses this annotation. So let's see this annotation, Spring Boot configuration annotation. So it is a class level annotation that is part of the Spring Boot framework. So what I mean by class level annotation is it is applied just above the class. See, we have our definition of the class, public class application, and you cannot apply this annotation at the rate Spring Boot configuration within the class. Means it has to be applied just above the class definition. Means wherever you have written your public class name, it has to be written above that. Means this is a class level annotation. It cannot be like applied to any method. It has to always be applied above the class name. So it implies that a class provides Spring Boot application configuration. It can be used as an alternative to Spring's standard configuration annotation so that configuration can be found automatically. Most Spring Boot application use at the rate Spring Boot configuration via Spring Boot application. Okay, we'll talk about this like Spring at the rate Spring Boot application, right? This is the most important annotation, and that at the rate Spring Boot application that internally uses this Spring Boot configuration. So if an application uses at the rate Spring Boot application, it is already using at the rate Spring Boot configuration. So no need to get confused here. See, at the rate Spring Boot configuration, what is the role of this annotation? The role of this is basically to help in the configuration of beans. When you use this particular annotation, it is providing configuration to your Spring Boot projects. So this is used for basically configuration purposes. Means a lot of config classes and those kind of things can be configured using this Spring Boot configuration annotation. And this is means there were some at the rate configuration annotations as well. So once you use this at the rate Spring Boot configuration, it basically takes care of your lot of configuration items. But we don't use this at the rate Spring Boot configuration. Means it is used internally by some other annotation, but we need to like understand this. So in Spring Boot, we will use a single annotation at the class level, and that annotation will be like very helpful. So we will see about that. But understand that the Spring Boot configuration, this the role of this is basically to provide configuration to our application, and this is used by the Spring Boot application annotation internally. Let's see another slide. See, enable auto configuration annotation. So this annotation auto configures the beans that are present in the class path, and it simplifies the developer's work by assuming the required beans from the class path and configures it to run the application. The annotation is part of the Spring Boot framework. For example, when we illustrate the Spring Boot starter web dependency in the class path, Spring Boot auto configures Tomcat and Spring MVC. The package of the class declaring the enable auto configuration annotation is considered as the default. Therefore, we need to apply the enable auto configuration in the root package so that sub packages and classes can be examined. Okay. See, so this is this public class application that is written. This is the main class. This class actually like basically helps in starting your application. This is the starting point of your application. Whenever we write something like public static void main, and in that class you will basically see this spring application dot run. So whenever you see this, right, so this class basically like bootstraps your application, or this class basically starts your application. So this is like your starting point of your application. Whenever you see this spring application dot run, so that is basically like starting your application. And what enable auto configuration does is it helps to like enable the configuration for the required beans from the class path. So it also basically helps in like enabling the Tomcat and Spring MVC features. So you need a server to run your application as well, right? Means whenever you have some application, you need a kind of server for running your application, and Apache Tomcat is that kind of server. So you don't have to like basically add that particular server in your application now. Means earlier when we used to create like Spring MVC projects, we needed to like install Apache Tomcat, and we needed to like add that to your projects as well. But now, means when you provide some kind of like this enable auto configuration, right, and you need to like provide one dependency in your pom.xml. Pom.xml I already showed you some time back, right, in the last to last slide, that in the pom.xml we need to add one dependency, that is spring boot starter web dependency. When we add that dependency, and in the Java application we write this enable auto configuration, then the Spring MVC features and that particular Tomcat Apache Tomcat server is automatically added to your application. So Spring Boot auto configures the Tomcat server and Spring MVC features. So we just need to like include the Spring Boot starter web dependency in our pom.xml, and just write this annotation at the rate enable auto configuration. So once you do these two things, means I'll again show this pom.xml. Here in this pom.xml, we will add something as dependency, and in the dependency, we will write Spring Boot starter web. You can see now, right? Here we have like Spring Boot starter parent. So similarly we will like add some one more dependency tag, and in that dependency tag basically we will be adding that dependency like Spring Boot starter web. And that is one thing, like adding the dependency of Spring Boot starter web. And next thing is you need to like write this annotation like at the rate enable auto configuration. So once you write this enable auto configuration, your Spring Boot auto configures your Tomcat server. It also auto configures your Spring MVC features, and it helps in the configuration of a lot of different Java objects. So this is the role of enable auto configuration. Let's go to the other slide. One second. So let's see the other slide. So this is about component scan. So component scan tells Spring in which packages you have annotated classes that should be managed by the Spring. So for example, if you have a class annotated with controller which is in a package that is not scanned by Spring, you will not be able to use it as a Spring controller. So we can say at the rate component scan enables Spring to scan for things like configurations, controllers, services, and other components that are defined. So generally component scan annotation is used with configuration annotation to specify the package for Spring to scan for components. Okay, so in short, what we'll understand is we have some component scan annotation, and we have like several classes which are like annotated. Let's say we have some service class, we have some repository class, and let's say we have some component classes. Means those classes are like some components, or those classes are like some service class or some repository classes. And what we want to do is we want our Spring Boot application to manage those particular classes. Like we have already provided some kind of annotation. Let's say we have written our repository class. So on that class level, we have like annotated it at the rate repository. And let's say we have some service class. We have annotated at the rate service at the class level. Now what we want to do, our Spring Boot application, when it is started, we want that the entire classes should be like scanned. Means your Spring Boot application should be able to scan the entire application and use that particular class as a Spring service, and use that particular repository as a Spring repository. Means a Spring repository and a Spring service has got special meaning in a Spring Boot application, but it's available only with the help of this component scan features. Means component scan is basically like, it is like scanning your entire code base and seeing what class is what. Means which class is basically repository, which class is controller, and which class is service. So component scan basically helps you identify or distinguish like which class is of which type. Means it helps you distinguish between a controller, a service, a repository, and some other component or utility classes. So that is the role of component scan. So it is used along with the at the rate configuration annotation. So we are using two annotations at a time, at the rate configuration and at the rate component scan. Now when we look at the next slide, right, your things will be like simplified. Means see, as of now we have seen these three annotations, like at the rate Spring Boot configuration, which was basically to manage the beans configuration and enable auto configuration. So the enable auto configuration was basically adding Tomcat server and Spring MVC features. It was also like helping you to like provide configurations to your Spring Boot framework. And there was then came this component scan annotation. So this component scan basically helps in scanning your entire code base, and it helps you to distinguish like which classes are termed as what. So it helps in basically scanning your entire code base, and that you have annotated, and you want those classes to be like managed by the Spring IOC container. Now the best part is you have learned about this three annotations, and when we will develop our Spring Boot application, you don't have to like use those three annotations. Means you just have to use a single annotation, and that basically is equal to like all these three annotations. Means with the help of that single annotation, you will be able to do the component scanning, you will be able to add the server, you will be able to like add the manage the Spring Beans. All those things can be done with the help of this at the rate Spring Boot application annotation. See, just read this. This annotation is used to mark the main class of a Spring Boot application. It encapsulates at the rate Spring Boot configuration, enable auto configuration, and component scan annotations with their default attributes. Means see, this class is again that main class where we are starting our application. You see this code, right? Spring application dot run, and in this run method we basically pass the class name of this, like demo application dot class, and we pass this args argument. So this class is the starting point of your application. Just see in the above in the previous examples also, this was the same class, means we were basically starting the class using spring application dot run, and we had a main method. I'll show the previous slides. See, in all the main methods we are using spring application dot run, and we are passing the class name. Here also in the second slide, see, in the main method we are basically passing spring application dot run, and we are passing the class name and the args argument. Here as well, when we are using spring boot configuration. So now we don't have to use those three annotations, we just have to like use a single annotation, and that is like at the rate spring boot application. And once you use this annotation, right, you will be able to use all the features of those three annotations. Means once you use this annotation, right, all the three annotations that you have basically at the what you have studied, like at the rate spring boot configuration, enable auto configuration, and component scan. So it is equivalent, this at the rate spring boot application is equivalent to sum of all these annotations. Whatever things are being done by these three annotations can be done by a single annotation. And this at the rate spring boot application basically like starts your application. It creates your application context of the application. It helps you to like initialize your Tomcat server. It helps you to add configurations to your Java objects. It also helps in component scanning. So this at the rate Spring Boot application is the most important annotation that you will be using in your class, and this will be in your main class, means the class which is basically responsible for like starting your Spring Boot application. So this is the feature of this Spring Boot application. So this is the most important annotation in Spring Boot. So this basically starts your application. This particular class will start your application, and once you provide this at the rate Spring Boot application, right, it basically enables the configurations, it enables your server, it enables the component scanning, and a lot more. So this at the rate Spring Boot application, we'll be using only this at the rate Spring Boot application, and we won't be using the previous three annotations. But the knowledge of those three annotations was required such that we arrive at this point that we understand this at the rate Spring Boot application. Okay, let's keep this class until this slide today. So we'll again miss maybe until tomorrow class also we will have some theoretical knowledge and concepts. Don't try to like skip those classes, because like those are like building blocks or foundations of your Spring Boot knowledge. Means writing code and all, if you will be also like able to create the projects easily even if you like skip a lot of the classes. But sometimes you might get messed up, like why this annotation was used, you might use a wrong annotation at some point. So try to like uh, try to attend that class as well. We might have some theory tomorrow as well. We'll see if we can like start our class, if we can like start with our project tomorrow. But we still need to like cover some theoretical concepts. And these annotations what we are discussing right now are like very important, and those will be like very important in like creating your project as well. So this if you have like any confusion or any doubts about this, anything that we covered today, you may ask, or we'll start with fresh topics tomorrow. We'll continue from here tomorrow.